Hello and welcome to this presentation out of the Networking Basics series. I am Apurva Todkar and I run the cixindia Academy. So if you are interested in any more content like this, the videos, the white papers and any other valuable resources, just head over to our website at www.dkix.in/dkix Academy. There's plenty of content waiting for you. So, but now let's get started with today's topic in the Networking Basics series. So this series is all about understanding how the internet works. So far, we have covered many topics like Ethernet, IP routing, UDP, and TCP in the networking basics series. We started off this with networking basics series last year in May, and then we moved on to some advanced topics on BGP. And the last topic that we did was on VLANs and QNQ, how QNQ helps customers to overlay their packet and to have a transparency or carrying multiple VLANs over an Ethernet segment that we saw last time. So let's take a moment to remember the internet model, also known as the protocol stack. So at layer 3, we have the IP layer where the data units are referred to as packets. So this layer is responsible for source to destination transport, and for that we need IP addresses. The key protocols used at this layer is IP version 4 and IP version 6. So about the internet layer, we have the transport layer. So this layer provides more sophisticated features such as flow control, reliability, and congestion avoidance. It also includes information about the next layer in the stack also. And some common protocols at the transport layers are TCP and UDP that you are already aware. And I've already created videos explaining both. If you go and watch the previous presentations that we had on the networking basics series, so you can check that out also. So if you haven't seen them yet, so feel free to check them out on our website. But there's another important protocol at this layer that we are focusing today, that is ICMP. So what is ICMP? ICMP is nothing but it stands for Internet Control Message Protocol. So now keep in mind that the IP stack is not as strict with layering as the OSI model. So if you remember, I had introduced both the OSI stack and the IP stack in the second video of this series, which we had in the networking basics. So ICMP uses IP for transport, meaning it is encapsulated within IP packets. However, it doesn't sit above the transport layer. In fact, there's nothing above ICMP in the stack actually. So it's often considered to operate alongside within the network layer. So to understand, let's take a step back and talk about the reasons how the packets behave the way they do in a network. We need to consider the situations that actually can arise while packets are being transmitted, and that's where ICMP plays an important role. So why are packets being sent in the first place? So usually it's because a user takes an action. For example, you tap on something on your phone, which triggers a request and sends out a packet to fetch some information. Or it could be a machine responding to an event like a door opening or an alarm being triggered, causing a message to be sent. Okay. So in general, packets are sent because some software or some application at the top layer needs to transmit data. So here, ICMP packets are a bit different. Unlike regular packets triggered by user actions, ICMP packets are often sent in response to network events such as errors or exceptions. So they are not generated by a human clicked on something, but rather by network devices like routers to report some unusual conditions like an error in transmission. So for example, if a packet is dropped or discarded, the router may send an ICMP message back to the sender to indicate that something had went wrong with this transmission. Like you can see in this diagram also that we had shown right now, that there was some problem with the transmission and it reported back to the original router indicating that something was wrong with the packet. So let me give you an example. So remember the IP header that we have seen in IP version 6, there's a field called as an hop limit, and in IP version 4, it's called as the TTL value, time to live value. So both serve the same purpose. So when a packet is created, this field is initialized with a value between 1 and 255, and it's commonly set to 64. So each time a packet is created, the field is initialized with the value, and each time a packet passes through a router, the hop limit or the TTL value is decremented by 1. So if it ever reaches 0, the packet is then discarded by the router. So if you take a look at our network map, you will see that the packet is originated with a hop limit of 64. So as it travels to the network, each router along the path decrements this value first to 63, then 62, then so on and so forth. And eventually it reaches a point where the hop limit is 1. When the next router forwards the packet, the value is reduced to 0. And at that point, the router must discard that packet. But it doesn't just silently drop it. It generates an ICMP error message and sends it back to the originator. So this ICMP packet uses the IP address of the router that discarded the packet, and it's the source address and the original sender's IP address as the destination, as you can see here in this diagram. So the ICMP type is set to time exceeded and the code field is set to 0. So in this side, it is set to 0. So additionally, the original IP header and the first 8 bytes of the discarded packet's payload are included in the ICMP message. So the sender can identify which got the error. So finally, the ICMP message is sent back to the original source of the discarded packet. So when the TTL value or the hop limits reaches to 0, the router discards the packet, and at the same time, it sends an ICMP packet of time exceeded back to the originator, like we saw. And the ICMP message includes just enough information, such as the original IP header and the part of the payload, so that the sender can identify which packet was actually discarded. So there are other ICMP message types also. So, and the one common example that I want to share is the destination unreachable that you must have seen. Have you ever seen any destination unreachable error message on your browser or application? So that's actually an ICMP message being sent back to you. So in this case, the ICMP type is 1 and the code field provides more specific information about the packet couldn't be delivered. So unlike the time exceeded message, which typically generated by the intermediate routers or the destination, intermediate routers, a destination unreachable message is usually generated by the target system or a firewall that indicating that the packet could not reach the destination. So here, the type ICMP type is 1 and the destination unreachable message is generated over here. So another important ICMP type is the echo request or the echo reply. So you are probably familiar with the command line tool called as ping. So this is one of the few examples where the ICMP packets are generated by the users. So when you ping, it sends out a message. When you ping, it sends out an ICMP echo request. And if the target system is reachable, it responds back with an ICMP echo reply. So now there's a slight difference between the ICMP for ICMP version 4 and ICMP version 6 when it comes to how these types are actually numbered. So in ICMP for IP version 4, the type values are assigned over times as new users, so new use cases were discovered. So they started to lower it as a lower numbers and then counted it back up. So for example, type 0 is for the echo reply and then type 43 is something more recent that's an extended echo reply. So in contrast to ICMP for IPv6, it was designed for a more structured from the beginning. So error messages using the ICMP for IP version 6 were usually in the values ranging from 0 to 127. So informational messages like the echo request or the echo replies were assigned typically from ranges from 128 to 255. Okay, so that was a quick wrap up on ICMP. What is the basic functionality of ICMP that I wanted to tell you? So we want to conclude on few points related to ICMP. And that is that ICMP is Internet Control Message Protocols, which plays a vital role in network signaling. So it uses to communicate errors, exceptional conditions, and some other important network information. So these messages are typically initiated by the users but are instead triggered by the events during the packet forwarding or the delivery. So, okay, so ICMP exists in both IP version 4 and IP version 6. Although there are different type values that differ between the two, but that doesn't matter because essentially they perform the same thing. So that was it about the presentation for the Internet Control Message Protocol. So this was just the basic overview that I wanted to give you on the ICMP. In the upcoming session, there would be uh, in-depth session on ICMP, but why the ping is considered as harmful when there's a network monitoring happening, or while during the transmission or an echo reply happening. In that, we will going to see what are the drawbacks or what are the issues that might arise due to an ICMP flooding also. So I hope this session was informative to our viewers. If there are any questions that people want to ask, feel free to ask if there's anything. If there are any questions, you people can drop down your questions into the chat box. Also, people can drop down their email IDs if they want this presentation slides to be shared with them over the email. There are no more questions. I'll think we are good to conclude. One more announcement that I wanted to make is that you people are from the ISP background. Already you are our existing customers, so you might be knowing that Google had notably changed that Google peering policy in April 2024, wherein they stopped giving their for the route server sessions and they only accepted bilateral sessions with the customers. But this year onwards, they have even stopped giving bilateral sessions to the customer over the exchange. So why are they doing this? Because they don't want to have that hassle with their end customers of establishing one-to-one BGP sessions. So in this scenario, DE-CIX has introduced a new product that is called as Google VPP. That is nothing but Google verified peering provider. So we are an official gold partner with Google, wherein we are eligible to provide Google traffic to the customers who are not able to have them getting served via the exchange. So now, like new customers who are getting onboarded, Google are not giving them any bilateral session for the Google traffic. So what we are doing is technically those customers are already peering with us over the route server sessions, and we are exchanging the Google routes with them through our ASN. We are directly connected with Google. So there is no as such difference that the customer would see. There is Google traffic ready to serve to our customers. So there's no as such thing that Google has stopped giving Google traffic over the exchange, so people will not be getting the traffic. There's not such a case. We already have the traffic. So anyone who is opting for Google traffic can obviously take from us. You can reach out to your sales account manager. They will surely help you out how to get that traffic. And why Google VPP is important for ISPs, because the major chunk of the ISP traffic is Google. Almost 40 to 50% traffic is of Google, then the Facebook, then Amazon, there, so on and so forth. So if there's no Google, there's no point of customer getting connected to the exchange. So if you have any queries or you need any technical help in terms of getting onboarded, feel free to reach out to our account managers. They will surely guide you how to get onboarded with us. Thank you.
Thank you for watching.